We just wrapped up energy and now we're ready to move on to waves. Now, we're going to see some energy concepts in the waves unit. However, waves is going to be a separate mini unit, and you will see some, like I said, some of the concepts from energy. If the substitute has not already passed out the yellow framing questions, please stop the tape and do so now. Otherwise, if you already have your framing questions, go ahead and write your name and class hour on the top. Now, with a couple of these framing questions, I have a couple of video clips we're going to look at. And if you take a look at the first question involves surfing. So I want to know who in this class has been surfing, who's been on a boogie board, who's been surfing out in the ocean, or who's tried to surf on a big wave pool. This question is going to be about surfing in the ocean. And before we get started with that, I want to go ahead and show a quick video clip. The first one is going to be beginner. Surfing for beginners. And I'm going to stop the clip at a certain point that we can look at so we can focus in on exactly what the framing question is asking. So watch.
We're at Surf Academy here in Swansea, South Wales, and I'm just going to run through certain topics with you. In this video, I'm going to show you how to learn to surf. So I'm going to show you very briefly how to catch a wave, how to pop up and stand and go across a wave.
So I'm going to stop the video clip right here, and I want you to notice a couple things. I want you to pay attention to the surfer. I want you to pay attention to the surfboard. And if there's a way that we could select one piece of water that's underneath the surfboard, that's what I'm looking for. So if you'll notice on the picture, I'm looking at one particle of water as the surfer is moving towards the shore. Because the question we're going to look at is going to be about that one particle of water. Now, if you consider the surfboard, this is a baby wave. However, there are lots of other kinds of waves that you can experience. And I'll see if I can get it over to my other wave so that you can see. All right, so the second wave we're going to look at, get it there. This is a wave in Tahiti. So once again, we're looking at the water in contact with the surfboard, but this is way more exciting and dangerous. So again, I'm going to stop it here, and I want to focus not on the big tidal wave that's crossing over the person's head. I want to instead focus on the particle of water that's underneath the surfboard. So let's go back to the framing question. The framing question that you have in front of you is asking about the particle of water underneath the surfboard. And it says, when a surfer catches a good wave, they can ride the wave all the way to the shoreline. Imagine you're tracking one particle of water underneath the surfboard. The moment the wave starts, the particle of water is under the surfboard. What happens to that particle? So what we're looking at in this situation, if I can use this picture as my example, if I could pick one particle of wave that is directly under the surfboard, I want to know what happens to that particle. So we have 4 different choices and then a 5th choice. Choice number 1 says the particle of water remains under the surfboard the entire time and moves closer to the shore at the same rate the surfboard moves to the shore. So that means the board and the water move at the same rate towards the shore. Now choice number 2 disagrees with that. Choice number 2 says the particle of water moves faster than the surfboard. Now, I'm not talking about the water that's over his head. I want to be very clear about that. Is the one particle that's underneath the surfboard. Choice number 3 says the particle of water moves slower than the surfboard, but eventually makes it to the shore. Choice number 4, the particle of water does not move to the shore at all. It remains in the same place. Then we have choice number 5. Choice number 5 is going to be, if you don't agree with any of those and you want to come up with your own, then you need to explain what that is. Now, if the substitute could stop the tape so that students can fill out their answers, and you all have done these before, so you know you need to fill out your answer in the Before Learning Content section on the left-hand side. So go ahead and do that now. Stop the tape. When you're ready, restart. So if you restarted the tape, we're ready to go on to question number 2. Now we know this unit is about waves. One of the waves that many of you have had experience with are sound waves. So the next question is involving sound waves. We've got several students that are discussing physics, and they're arguing about what they hear when 2 sound waves interact. And there are 4 different arguments. So once again, there are 2 sound waves that are interacting. Student 1 says that the sounds get louder when the 2 waves interact. Student 2 says that the sounds actually get quieter if 2 sound waves interact. Student 3 argues that the sound doesn't change, and even though the 2 waves are interacting. And then we have argument number 4. Argument number 4 is that the sounds can get louder and quieter, or they could also not change at all. So once again, select the one argument you agree with. What I want you to do is to explain who is right and why. Now if you'll notice, it says to flip it over, turn the page, and that's where I want your explanations to go. Stop the tape. When you're ready, you can move on. Now, the last one involves a whale. And this whale actually can communicate underwater, as many of you already know. And you know that sound can travel through air. You also know that whales can communicate underwater and sound can travel through water. When a high-pitched sound is produced in air and then travels in water, that's what we want to look at for the third framing question. So the scenario says to circle all factors that you think will change when a sound wave is going from air to water. So it starts off in air and then goes into the water. And we want to explain how you think the sound wave will change and why you think the sound wave will change. So back here, if you've never heard the sounds of whales underwater, this is what it sounds like. All right, so back to our framing question. There are 3 things that you're looking at. You're first going to look at the frequency or the pitch. Frequency or pitch. Now, the question is, does frequency or pitch change whenever the sound waves goes from air to water? If you think it changes, then circle frequency or pitch, and then explain how do you think it changes and why do you think it changes. Do the same thing with wavelength. How do you think it changes? Why do you think it changes? And lastly, what about the speed of the wave? How do you think it changes? Why do you think it changes? And once again, only circle those factors that you believe will change. Make sure that you're filling out before learning content thoroughly, and then you'll turn it into the substitute to hang on to till at the end of the unit. And that's all. Substitute can stop the tape now.